Okay, before we get into new material for the course, we're going to run through and review differentiation and integration from your previous course. So this note packet, which I just titled Review, covers material from chapters 2 through 6. The chapter 6 material might not be review, but I wanted to put it in this packet to keep it separate from the real new material for this course, which is chapters 7, 9, and 11. In case you don't have your text from Math 130, although hopefully you held on to it, the homework problems for the packet we're going to look at here are at the back. So I'll just scroll down so you can see them. So if I scroll past all the material, somewhere back here, almost there, this is where the problem sets start. So for the first part, the chapter 2 through 4 review material, these are your homework problems. There are answers here. Hopefully they're correct. Just shoot me an email if you think there's a typo. So whenever we come back to this packet and do material from chapters 2 through 6, the homework problems are here. So here's the chapter 5 and then chapter 6 stuff. Okay, so keep this packet handy. And so what we're going to do in the first part here is just a review of your rules for derivatives. All of this stuff should come back to you pretty quick. But it takes a little bit of time. We got to go through this. We are going to extend things to multivariable functions, and the good thing is none of your rules for differentiation change. So all of these rules in this box here still hold. So there are no new derivative rules. What there will be is a new awkwardness. And you always get over that kind of awkwardness, just like you did in your previous course, once you got comfortable with these rules. So I just want to, in the first section here, review these rules a little bit. So they're here for reference, just as a reminder. Hopefully you have your notes from your previous course. You can refer back to those as well. I just want to go through and do a bunch of derivative problems to kind of get back into the groove. Another thing that I'll do with this review packet is we'll kind of come back to this packet as needed. So we'll review the differentiation stuff, chapters 2 through 4, before doing the first part of chapter 7. Then we'll come back to this and review integration and do the last part of chapter 7 and the rest of the course. And then before we do chapter 11, we'll come back and do section 6.3. So we'll keep kind of bouncing back to this section, or to this packet of notes. So let's go through and just do problems. One thing you should do when you're watching these videos is try to pause the video here and do these problems. And then play through the video to check your answers and, kind of pause and see where things may or may not be going wrong. Also, make sure you refer to the annotated versions of these notes that are also on the website. There's possibly some different information than what comes up in the videos, where I might have more time to think and write proper things down, whereas here we're just kind of flying through. So let's dig into this. This first problem here, what we're going to need to employ are the sum, constant, multiple rule, and power rules. Okay, this is the sum of several different functions. So your sum rule is your first rule here, and what the sum rule says, if you look back above, is that you can just take the derivative of each term individually and add the result. Also, we can deal with constants in the same way. So all we're really going to have to worry about are our power functions. So the first thing I would do here is prep this. We know that there's nothing in that box up above that deals with root symbols, things like that. So a little bit of algebra prep would be good. So we can write this as 3x to the fourth minus 4x to the 1/2 Remember, your roots are 1/2 power. And then this 5 over x squared I can write as 5x to the negative 2. So we can use negative exponents to bring that up. And then we have minus 7. Okay, so now we're ready to take the derivative of y with respect to x. And we're just going to do all 3 of these rules as we go. So the way I do that is I am going term by term, so I'm applying the sum rule. I'm going to just write the constants down, so I've done the constant multiple rule. And then we can apply the power rule to x to the 4th. And remember, the exponent comes down, and we subtract 1 from it. And then we'd have 4 times 1/2 x to the 1/2 minus 1 would be negative 1/2, plus 5 times negative 2x to the negative 2 minus 1, or negative 2x to the negative 3. And then the derivative of a constant, that's one of our rules up above. Oh, it's not in that list, but this is a constant. And what is the derivative? Derivative is slope, and a constant is a horizontal line which has slope 0. I should have had that in the box up there, but that's one you probably remember. And then all we really need to do is just clean things up. So this would be 12x cubed minus 2x to the negative 1/2 minus 10x to the negative 3. And that's it. Okay, so let's look at the next one here. This is a quotient, so we're going to apply the quotient rule. And I always write this in a particular order. So the problem with the quotient rule is there is subtraction on top, so the order matters because subtraction is not commutative. So what I always do is start out by squaring the bottom and writing the bottom down again in that first spot here, and take the derivative of the top. Now the order is correct up above. And then we would have minus, and then we switch the order. So it'll be the top 5x squared minus 3x plus 2 times the derivative of the bottom, 1 minus 2x. So the reason I start this way is so that the first function I differentiate is the numerator because of the subtraction symbol here. So via the quotient rule, I do break this down again into the first example where I'm just doing the sum, constant multiple rule, and power rule. So this will be 1 minus 2x. The derivative of 5x squared minus 3x plus 2 is 10x minus 3. And then over here we have minus 5x squared minus 3x plus 2. And the derivative of this is just the equation of a line, and its slope is negative 2, so that should be the derivative. All this is over 1 minus 2x squared. And so this simplifies. If you go through and multiply everything on top, this is negative 10x squared plus 10x plus 1 over 1 minus 2x squared. Hopefully my writing is legible. This is kind of awkward in that I'm writing on a Wacom tablet and looking up at a television screen while I'm doing it. So if you think about it, usually when we handwrite, we're kind of looking down. So that's it for those first two. One thing you might note on the first example, I didn't write that back in radical form, or this without the negative exponent. So you could write this as 12x cubed minus 2 over the square root of x minus 10 over x cubed. I'm generally not interested in doing that unless I know there's a reason, like if I'm doing it for some algebraic purpose. You'll be doing it to check your answers the way they show up in the back of the textbooks. But I'm totally fine with what's in the box. I must be because I put a box around it, so it's got to be the correct answer. But if you want to go one extra step, you could do that. Generally, I don't bother unless I know why I'm doing it. So let's scroll down here and look at the next couple. Both of these require the chain rule. This first one, what we have is a very first step, I suppose, would be the constant multiple rule. Worry about that too. And then we have to take the derivative of e to the 3x plus 5, which requires a chain rule because this isn't just e to the x. Well, the derivative via the chain rule is the derivative of the outer function. The outer function here is e to the x, evaluated at the inner function. So with exponentials, you always get the original back, times the derivative of that exponent. So hopefully this is coming back a little bit. It'll take a little bit of time, but it will come back. It has to. And then this is just 3. So 2 times that 3 would give me 6e to the 3x plus 5. And that's it. So the chain rule for e to the stuff is always just e to that stuff times the derivative of that stuff. So your inner function here is 3x plus 5. Looking at part D here, we have some stuff to a power. So we have a function to a power that hints at a power rule on the outside, which would give me 3/2 times some stuff to the 3/2 minus 1, or 1/2, times the derivative of that stuff. So the chain rule here has the same form as in the previous example. We just have a polynomial here instead. A polynomial inside a power function instead of inside an exponential. But the process is about the same. And so again, via the chain rule, we're down to just having to deal with the power rule, sum rule, and constant multiple rule. So if we can keep breaking things down in the power rule, we're in pretty good shape. But you have to know the product quotient and chain rules to get you there. And then our specific derivative rules for e to the x and the natural log of x. So if I finish this off, I have 3/2, 3 minus 4x plus 3x squared to the 1/2. That's an x there. And then over here, the derivative of 3 is 0. Derivative of negative 4x would be negative 4. And the derivative of 3x squared would be 6x. I'm just going to leave it there. You could distribute the 3/2 through this last term, but I think that looks good as is. We like things factored. If I were going to do anything here, I would factor a 2 out of the last term, just to cancel the fraction. But I think that looks good there. So hopefully this is starting to come back. We're going to do more derivatives on the next page, so let's head to page 3.